Hi, welcome back. Today we're going to take a look at applications of differential equations. A very neat little skill, very important, especially on the AP test. So one thing I want to kind of remind you guys, remember when you're solving a differential equation, we must show every step. Now this is a lot of points we're talking about on the AP test. This is the one topic, remember we talked about, where the AP is specific about the work needed. Not too many shortcuts that we have. So let's look at an example, kind of a review for us. We want to solve the differential equation for y. And remember, anytime they say the word differential, they're really kind of talking about a derivative right here. And if we're solving the differential for y, they're saying, well, to solve a derivative equation, we know we have to use antiderivatives. So let's take a look at the example that we have right here. We're given this derivative for x cubed y plus 20x cubed. And they give us this initial condition, which we'll, of course, work with later on. So to solve this, the first thing we have to do, of course, is separate our variables. But you might notice this one's a little bit different to do because this is not a multiplication that we can easily bring over, or an addition, or something like that. So to do this one is, to solve this one, we have to factor. So in both terms, we can factor out a 4 and x cubed. So I can rewrite my derivative, dy dx, as 4x cubed, and this becomes times y plus 5. And now this is going to allow me to separate my variables. Remember, to separate your variables, you have to use multiplication or division. We can't use addition or subtraction. So that's why we wanted to factor this problem out right here. So this y plus 5, this is going to go over, and the dx is going to go over, and is going to be moved over. So we would get this 1 over y plus 5 dy equals 4x cubed dx. When we now integrate both sides, now the antiderivative of 4x cubed is pretty easy. This just becomes 4x to the 4th over 4, or we get x to the 4th. Don't forget your constant of integration, that plus c1. But to integrate the 1 over y plus 5, we're going to use our u substitution. U is this y plus 5. Du is just dy. And that's nice. It means that I'm not really going to multiply anything. So this becomes, remember, using the shortcut, this becomes 1 over u. The antiderivative of 1 over u is natural log of u. So we're going to get the natural log of u, but remember we said u is this y plus 5. So we get y plus 5 here. And now we do our favorite things in the world to do. We're going to exponentiate both sides. And that's going to give us, with the absolute value of y plus 5 equal to, remember, we're going to use this little algebra trick, e to the x to the 4th times e to the c1. Right here. And remember, this is just our little exponential rule. If I'm adding exponents together, means that if I'm adding the exponents here, means I was multiplying with the same base. And don't forget, we want to rewrite this. We wrote this for a purpose. E to the c1 is just a constant. So we're now going to rewrite this as, we're going to say, let e to the c1 equal c2. And you're going to write that down to get full credit. And now so this now becomes the absolute value of y plus 5 equals c2 e to the x to the 4th. I replace my e to the c1 with c2. And if I were to solve this, get rid of the absolute values, y plus 5 equals plus or minus c2 e to the x to the 4th. So this is our general equation. And now what we have to do is, of course, solve for our c2. So now we're going to find c2 using the condition they gave us, 1, negative 3. Now be careful. Remember, over here we have two options. We can have the positive or we could have the negative. Well, over here my y value is negative, so we're going to pick the negative. So we would say y plus 5 equals negative c2 e to the x to the fourth. And then you plug in your point. We would get negative 3 plus 5 equals negative c2 e to the x to the fourth. Whoops, x is just 1, so there we go. So 1 to the fourth. So what we wind up with, remember, don't put the 1 there. I forgot to do that. So what we're left with is 2 equals negative c2 e. So therefore c2 equals negative 2 over e. Now, when I write my equation, be very careful of the signs. When you write your equation, we would get this y plus 5 equals a negative of a negative, which becomes a positive 2 over e, e to the x to the fourth. And that would be our equation right there. All right, join us for part 2. We're going to take a look at some applications. And these are definitely big on the AP, and I will see you then.